Hi, my name is Cameron Weist, and today we are going to be going on an intergalactic space mission across Jupiter's moons. As you can see to my right, we have the Galilean moons pictured. This image has them in order of size. However, we will be discovering each moon based on their placement from Jupiter. That order will be Io, Europa, Ganymede, and Callisto. Before we get started, let me introduce you to Galileo. Galileo was an Italian astronomer who discovered Jupiter's moons in 1610, hence the name the Galilean moons. NASA states that when Galileo first saw the satellites through his homemade telescope, he thought that they were stars. However, he analyzed them over several nights and noticed they moved in opposite directions of the surrounding stars, while staying in a closer proximity of Jupiter. Therefore, he concluded that they were moons. Now, let's blast off from Earth and commence with our journey to the Galilean moons.
3, 2, 1, 0, and liftoff! Liftoff. Americans return to space as Discovery clears the tower.
This is Io. Before we begin with some fun facts, I want to address all the basic characteristics of this moon. Io has a density of 3.5 grams per cubic centimeter. It has an orbital period of 1.8 Earth days. All the Galilean moons are tidally locked to Jupiter, meaning that the same face of the moon is always facing that planet. It has a radius of 1,821.6 kilometers, and it also has a reflectivity of 60%. Fun fact, Io is 422,000 kilometers from Jupiter, meaning it rests in the plasma cloud around Jupiter known as the Io plasma torus. This strips ions from the moon, basically making it an electrical reactor and resulting in a radiation that is 1,000 times stronger than the level necessary to kill a human. So it is noticeably clear that there's probably no life on this moon. As we can see from this image, Io has a yellowy color to it. This is due to the molten sulfur that comes from the planet's volcanoes. Io is the most volcanically active body in the solar system. There are more than 200 known volcanoes on this moon's surface, and approximately 25% of Io is covered in molten lava. The lava is made of molten silicates, and the bright colors of Io's surface is due to a variety of sulfur compounds, including molten sulfur and sulfur dioxide clouds. Here is an image of what Io's surface is perceived to look like, interpreted by an anonymous animator. The volcanic activity is driven from the tidal flexing caused by the poles of both Jupiter and Europa. This creates extremely high surface temperatures, which leads to the active eruptions on the surface. Now, let's load back into our rocket ship and head straight to our next destination, Europa. Here we have Europa. This moon is 671,000 kilometers away from Jupiter. It has a density of 3.0 grams per cubic centimeter. It has an orbital period of 3.5 Earth days, and it has a radius of 1,560.8 kilometers. It also has a reflectivity of about 70%. As you can see, Europa appears to have a very smooth surface, which makes sense why its reflectivity is also so high. Additionally, it is so smooth with few crater impacts because the surface keeps renewing itself. As you can see, there are cracks on the surface, which is evidence of tectonic plates, meaning that Europa's ice does not actually go straight through to its core, but instead floats and moves on the surface. Fun fact, Europa is known as the ice moon, and NASA has stated that it is thought to have twice as much liquid water as Earth. This moon has been researched more intensely than the others because it is believed to have the potential of having habitable life, as its oceans are very similar to Earth. On Earth, we have discovered the existence of life in the very depths of our ocean, which is why it is seen to be possible in the depths of Europa. Here is an interpretation of what Europa's moon may look like on the surface. Now, our intergalactic space mission continues as we head to Jupiter's largest moon, Ganymede, which is 1,070,000 kilometers away from Jupiter. Let's load into our rocket ship and continue on our journey. Ganymede has a density of 1.9 grams per cubic centimeter. It has a radius of 2,631 kilometers. This makes it not only Jupiter's largest moon, but the largest moon in our solar system. In fact, it is even bigger than the planet Mercury. It has an orbital period of 7.15 Earth days. And isn't it weird that Europa's orbital period is twice that of Io's, and Ganymede is twice that of Europa's? Therefore, every time Ganymede goes around Jupiter, Europa goes around twice, and Io goes around 4 times. It also has a reflectivity of 40%. Did you know the older the moon, the less it reflects? This is why Ganymede's reflectivity is so low, as it is estimated to be 2.3 billion years old. A fun fact about Ganymede is that it is the only moon known to have an internally generated magnetic field, which is believed to be a convection of its liquid iron core. This magnetic field also implies a layer of a saltwater body. NASA believes it is possible that Ganymede has a subsurface saltwater ocean that contains more water than all of Earth as a whole. Additionally, parts of the surface can be assumed to be only a few million years old because of cracks and flooding from the water. Ganymede is a differentiated body, which means that the planet has a distinct layers, and when it was formed, more dense materials, like the iron, sunk to its core, and less dense materials surrounded the outer surface. It's time for our last stop. Let's blast off to Callisto. This is Callisto. We are now 1,883,000 kilometers from Jupiter. This moon has a density of 1.83 grams per cubic centimeter. If you haven't noticed, as we get further away from the planet Jupiter, the density of every moon decreases. This moon has an orbital period of 16.7 Earth days, has a radius of 2,410 kilometers, and has a reflectivity of 20%. Callisto is also very heavily cratered, maybe even more so than Ganymede, and has an estimated age of 2 to 3 billion years old. It is one of the oldest surfaces in the whole solar system. Callisto has 2 big mysteries, the first being that it is not differentiated, which is very odd for a moon of this size, especially because its ice melts at a fairly low temperature. The second is that the moon is perceived to be stillborn, meaning that it has always been geologically dead. Additionally, Callisto is a very cold moon, which means its ice can get as hard as a rock and actually sinks to the bottom of its water bodies, which is the same as what occurs on the surface of the moon Ganymede, which is very different from Europa because that moon has tectonic ice plates on its surface of its water. I want to thank you for joining me on this adventure, and now it's time to venture back to Earth. On our intergalactic space mission, we learned of the basic characteristics of the Galilean moons. Additionally, we also learned about some fun facts. All the facts that I've provided came from NASA, the planets.org, or the Openstax space textbook. And proper citing of all the resources are seen down below in the description. For full disclosure, we cannot actually take a spaceship from Earth to each Galilean moon from one another, with the technology that we have currently available. Once again, thank you, and I hope you enjoyed our mission to the Galilean moons.
I wanna go faster, faster, hands in the air, we're gonna crash, searching for the answers, like Galileo through his looking glass. Thirst for reason, our dreamer's eyes we gaze into, a sense of purpose, no my view, like finding water on